All right, guys. So in this video, we're gonna go and solve this equation that I started earlier. So here's the equation: x plus 3y minus 7z equals 14. Second equation, 5x minus 3y plus 2z equals negative 3. And my last equation is negative 2, 4y minus z equals 7. All right, and so what I want to do is write it so that it's in matrix form like this. I'm going to only use the uh, coefficients, okay, of the equations here. And then I'm going to try convert this into what's called Gaussian elimination, okay? And this is called the identity. And so if I can convert these numbers to become zeros, okay, and have the diagonal become only ones, then that will give me my answer. All right, so ideally, that's what I want to do by taking rows, multiplying them, and adding them, and such like that. So let's start. And remember, it's very specific. You want to go in order, okay? You want to go convert 1A first, B, C, okay? You want to make these guys, A, B, and C become zeros first, and then D comes next. And then you want to do E after that, and then F in this specific order. You got to do it in this order. You make A become 0, B becomes 0, C becomes 0, D, E, and F to be all become zeros. Once you're done, if you're able to do that, then you'll get your X, Y, and Z. Okay, so here's what we're going to do. We're going to take the equations we started with first. Okay, so our first step, we're going to do, for example, we're going to take 5 row 1, and we're going to subtract, okay? We're going to subtract row 2, okay? So we're going to take row 1 multiplied by 5, and that's going to give us 5, 15, negative 35, 70. And then row 2, okay? Well, to do less confusing, okay, what I would like to do is, I like to always add, okay? So what I want to do is I want to add, but to do that, I'm going to multiply by everything by negative 5 then, okay? I'm going to take negative 5 times row 1 plus row 2. So that's going to change my numbers over here a little bit. It'll be negative 5, negative 15, 35, and negative 70. So what I'm doing is I'm taking row 1 up there, I'm multiplying by negative 5. And now my row 2, I'm just going to leave it alone. My row 2, I'm going to write 5, negative 3, 2, negative 3. Okay, so now what I'm going to do is going to take the answer to this. Okay, when I do this, when I add, I'm going to get 0. All right, I'm going to add the second column. I'm going to get negative 18. Then here for the z's, I get 37. And then my answer will be negative 73. Okay, so now what I did was I created a brand new equation. This equation I can put anywhere. This equation, now I'm going to replace it with the original row 2. I'm going to take row 2 out, right there. I'm going to take row 2 out. I'm going to put this guy in its place. So first row is going to be 1, 3, negative 7, 14. My second row now is going to be this new guy. 0, negative 18, 37, and negative 73. My third row, it's going to stay the same. It's negative 2, 4, negative 1, and 7, okay? That's my third row. So what I did, my step 1, was I got A to become 0, okay? So now here's my new and improved matrix where A is 0. Now my job is to take this guy, B, okay, it's currently negative 2, and I want it to go away. I want it to be 0, okay? So in this case, I can do anything I want by mixing and matching these 3 rows. So in this case, I want to take 2 row 1, and I'm going to add this with row 3. Okay, so I'm going to take row 1 multiplied by 2. That's going to give me 2, 6, negative 14, and 28. I'm going to take row 3. I'm just going to leave it alone. Negative 2, 4, and negative 1, and 7. Okay, so now I'm going to add these two together. When I add that, I'm going to get 0, 10, negative 15, and 35. Okay, so this is my brand new equation that I created. Now, the benefit of this brand new equation is that, see, that first number is going to be a 0. So now I'm going to replace it with this guy. I'm going to replace this last row with this new one I got. So my new matrix will be 1, 3, negative 7, and 14. Second row is going to be 0, negative 18, 37, and negative 73. My last row is going to be this new guy, right? 0, 10, negative 15, and 35. Okay, so now, see how that is? Now I have A is 0, B is 0. I got to work on C now. I got to make this guy become 0. But I don't want the zeros to regrow, okay? I want to make the 10 become a 0, but not make the zeros I already had come back to be regular numbers. I don't want that. Okay, so to do that, if you remember, it's called the least common multiple of negative 18 and 10. We're going to do, let's see, we're going to do the least common multiple of negative 18 and 10, and that's going to be 90. So we're going to make these guys negative 90 and 90, okay? So we're going to take 5, row 2, and we're going to add this with 9, row 3, okay? So now we're going to multiply the second row by 5. So 0, negative 90, 185, and negative 365. We're going to multiply 9 to the third row. So 0, 90, negative 135, and positive 315. When I add these guys up, I'm going to get 0, 0. And that's going to leave me with 50. And the right-hand side is going to be negative 50. But there's something special about this brand new equation. Okay, this brand new equation is reducible, right? 0x, 0y, 50z is negative 50. So what we want to do is reduce every single time, every equation we can, this equation, at the end we want to reduce. So it's better reduced to be 0, 0, 1, negative 1. Okay, so I'm going to take this brand new equation and put it to the last right here. So my new matrix will be 1, 3, negative 7, 14, 0, negative 18, 37, negative 73. And then now my new guy, 0, 0, 1, negative 1. There you go. So what I have here is that this bottom equation says z equals negative 1. Okay, I just got to get rid of D, E, and F, and I'll get my whole answer. Okay, now at this stage, it should be pretty easy now. Okay, now I will take negative 37, row 3, and I'm going to add this with row 2. So that's going to give me 0, 0, negative 37, 37. And row 2 is 0, negative 18, 37, negative 73. When I add these together, I'm going to get 0, negative 18, and 0, negative 36. Here's my brand new equation, okay? But notice, see how it's reducible? Since it's reducible, I'm going to reduce it. Okay, I'm going to reduce it to be 0, 1, 0, 2 by dividing everything by negative 18. So now I have 1, 3, negative 7, 14. Now my second row is going to be 0, 1, 0, 2. My last row is 0, 0, 1, and negative 1. Okay? Now, what we want to do, we already have this right here says z equals negative 1. And see this middle row, row 2 says y equals 2. Okay? So we're going to continue on, and we're going to solve for x. You can solve for x in a couple ways. You can substitute if you want to, or we just continue going on. Okay, so to continue this process, okay, I'm just gonna keep on going. I want to get rid of this negative 7. Okay, I'm gonna make negative 7 become 0. This guy right here. So to do that, I want to match it up with row 3 again. Okay, so 7, row 3, I'm going to add this with row 1. Now, when I do that, I got to multiply row 3. Okay, I got to multiply row 3. Okay, multiply row 3 here with 7. So I'm going to get 0, 0, 7, negative 7. And I'm going to add this with row 1. Row 1 is 1, 3, negative 7, and 14. Okay, so now I'm going to add these. By adding these, I'm going to get 1, 3, 0, and 7, right? So here's my brand new equation. The good thing about this equation is that E is 0. I'm going to replace it up there. My matrix now, okay, matrix now will be 1, 3, 0, 7. Second row 0, 1, 0, 2, 0, 0, 1, negative 1, like that. Okay, now we only have this guy to eliminate. Just get rid of the 3. Okay, you want to match it up with row 2. So negative 3 row 2 plus row 1. Okay, so hopefully you're catching on. So 0, negative 3, 0, negative 6, 1, 0, 0, 7. Now when we add these, 1, oops, sorry, this is a 3. Okay, so now when we add, it's going to be 1, 0, 0, 1. And this is my brand new equation. Okay, and I'm going to replace it with in here in row 1. So 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, negative 1. And what I was aiming for the whole time was this. And so I was trying to get 1s on the diagonals and everything else 0s. And here's my answer on the right hand side. My answer is 1, 2, negative 1. Okay, again, this process is called Gaussian elimination. And that's how you do it. Hopefully you're able to do that. Try a couple problems at home. Okay, all right, good luck.